So we've had a question on number 3, so I'm going to go ahead and look at that one. So I do need full attention, please. So we can go ahead and look at this. Okay, so number 3, it says the base of a solid is the region in quadrant 1 enclosed by the y-axis, y equals 4, and x squared. So let's just get that visual to help us understand what's going on. So we have quadrant 1. We have the curve y equals x squared. So that's going to be, let's see, 1 and 1, 2 and 1, 2, 3, 4. So we have kind of this curve right here, right? So that is y equals x squared. And then it tells me that it's enclosed by the y-axis and the line y equals 4. So right here we have the horizontal line y equals 4. So the area that we're looking at is going to be this area right here. And I know it's that area, even though my parabola does go and cross over there. Are we looking at the that left area? No, just the right area, because we're enclosed by the y-axis, and it tells us that we're in quadrant 1. Now, there is a little bit of a trick or a spin on this that they throw at you. Okay? Yes. Is that they say that the cross sections are perpendicular to the y-axis. So, we are not doing vertical cross sections. That would be easy. Of course not. Why would we want to make this easy? Instead, we are doing horizontal cross sections. So everything needs to be in terms of y. Okay? So I need to look back at my y equals x squared, and let's go ahead and solve for x. Well, what do I need to do to solve for x on this one so I get it in terms of y? Just square root both sides. But I have an issue, plus or minus y. So if I could have your attention up here, which one is it going to be, the plus or the minus? What do we think? Anthony? The one that we were concerned with is that positive side. So how do we know which one's the positive, which one's the negative? Well, this is the positive side, this is the negative side. Okay? And so all I need to look at is that positive, square root of y. So that's the one that I want. So we are looking at, so I'm going to change this and say this is going to be x is equal to square root of y. So in this case, we are only going to look, I'm going to bold this one so we know we're only looking at this side. That's the only one that we are concerned with. Okay? All right, now let's go on. Let's see, it says the cross sections are rectangles. So let's talk about what our cross section looks like. So our cross sections are rectangles. And what do they tell us about those rectangles? The height is half that of the side in the x and y plane. Well, what side is in the x and y plane? The base. This is my xy plane, right? My base is lying in that xy plane. Remember, if we were to think about this three-dimensional, right, I would have my parabola going up, my line going like that, and I would have my z curve, or z-axis. And so all my rectangles, their base is in that xy plane. The rest of it is coming up. right? Like so. So when it says that are in the xy plane, it's going to be that base of the rectangle. That base is down there. So the height, if this is my base, the height is what? What are they saying the height is?
Half of that.
Half of that.
So 1/2 b.
1/2 b. So then what is my area going to be?
1/2 b squared.
All right, but then let's think. What is my, let me actually write that over here. X equals 1/2 base squared. But what, how do I express my b? How do I express that b?
4 minus y. Just the square root of y. Oh.
Just the square root of y. Because remember,
y equals 4 is just a bound.
exactly, that y equals 4 becomes now just a bound.
Our other function is basically just defined when it says it's in quadrant 1. It gives us that line.
Yeah. So we have the right side is our function square root of y, and our left side is the y-axis. So we could theoretically, going right minus left, I could write that as square root of y minus 0, because we are bound, the lower bound is that y-axis. Okay? That y equals 4 is no longer an upper bound. That is now it is an upper bound, but it's the bound, the interval of integration now. So our interval of integration goes from 0 to 4. Okay? So that's how that's going to work. Because remember, we have to kind of tilt our head to the side. And when we tilt our head to the side and look at that sideways, then this becomes kind of the top, and this is the bottom, this is the left, that's the right, more or less. Okay? All right, so I can go ahead and plug that in. So that becomes a of x equals 1/2 times the square root of y, well squared. But what happens when I square a square root? Cancels out. So this is actually really nice. It's just 1/2 y. Makes it very easy for us. So how do we express our volume now? Volume is equal to the integral from? It's going to be 0 to 4. And remember, we're in terms of y now, so that'd be c to d of our area function. Oh, and I made the same mistake that I did yesterday. This should be a of y. I just automatically do a of x. That should be a of y dy. Everything's in terms of y. And yes, like you guys said, 0 to 4. And that's going to be 1/2 of y dy. And that one is very simple. We don't even need to use our calculator. I can just go ahead and say that's going to be 1/2 of y squared divided by 2 from 0 to 4. So that's equal to 4 squared divided by 4 minus really just 0, because when I plug that in, that's going to be 0. Well, what's 4 squared? No. 16. 16 divided by 4 is? And there's our answer. There we go. Yes?
When we're doing integrals in terms of y, we still have our bound from lowest to highest.
Yes.
So we don't go like left to right.
No, it's now bottom to top. Yeah. Bottom to top. Low value to the high value. Because if you did it reversed, your answer would come out negative. Right? And we don't want to have a negative area. All right. So that's number 3. Any clarification needed on number 3? Okay.